Now let's take a problem based on a truss which is asked in GATE 2004. This one for GATE AME 2004. In this problem they have given a truss which is shown in figure. I am just drawing the truss here, and these are the members of the given truss, and the points are O, K, L, M, L, N, M, and at point M we are applying the load of 100 kilogram. At K point there is a hinge joint. At O point there is a roller support. So this one is the given truss, and in this problem we are interested in force in member Ln. So we have to find out force in member Ln. So for solving this problem quickly, just draw the free body diagram of joint L. So if you draw the free body of diagram of joint L, so joint L there are three members as shown in figure. And now according to our assumption, all the forces in the member of a given truss are tensile. So for showing the forces, tensile forces in the members, arrow should be away from joint, away from joint, away from joint. So this force will be F Lk, this force will be F Ln, and this force will be F Ln. And if you see the diagram, there is only one force in a vertical direction. So just apply the equilibrium condition based on vertical forces, that is algebraic summation of all vertical forces should be 0, means algebraic summation of all the forces along y axis should be 0. So according to our sign convention, upward direction is positive, means positive y is positive, downward is negative, means negative y is negative. So in vertical direction there is only one force, Fln, which is in downward direction, so negative, and it should be 0. So Fln will be 0 Newton. So this one is the correct answer for this problem. Let's take a problem which is asked in GATE 2003. It is EM GATE AME 2003. In that problem, a truss is given as shown in figure. I am just drawing the truss here. I am drawing the members. This is the given truss. This is point A. This is point B, C, D, E, and F. At EF, there is a uniformly distributed load. There is a uniformly distributed load here. And at A point, there is a roller support. And at B point, there is a hinge support. And the length of each members is L here. So obviously the inclination of member AE will be 45 degree, which is making an angle 45 degree with the horizontal. Similarly, DE also make 45 degree, BF also make 45 degree. And this one is the uniformly distributed load, and intensity is P per unit length. That is P per unit length. On unit length, there is a load P. Now we have to find out the force in member C. So find force in member CD. So we have to find out force in member CD. And I am again repeating this question. This one is the given truss here. The length of each member is L. A is supported by roller support, and B is supported by hinge support. And the load here is only on EF, that is uniformly distributed load and intensity is P per unit length. And now we are interested in forcing member CD. So now just to find the reaction at the support first. This one is roller support, there will be reaction RA, and this one is hinge support, so there will be a two reaction, horizontal and vertical. But in given truss there is no horizontal force, so there will be no horizontal reaction. That's why I am showing only vertical reaction, that is R. Now apply condition based on the vertical forces, equilibrium condition based on vertical forces. That is, algebraic summation of all vertical forces should be 0. For forces along y direction should be 0. So positive y is positive, negative y is negative. So RA is acting in upward direction, so positive. RB is acting in upward direction, so positive. And this intensity, that is P per unit length, is acting on the L length, so total load will be P into L. So total load will be P into L. It is acting in downward direction, so negative equals to 0. So RA plus RB equals to PL. This one is the first equation we are getting by this. The condition, that is algebraic summation of all vertical forces should be 0. Second condition of equilibrium, algebraic summation of moments of all the force about A should be 0. The RA is passing through the A, so perpendicular distance is 0, so the moment is 0. So I can write RA into 0 because perpendicular distance is 0. We know the total load due to this uniformly distributed load is PL, and it will act at the center of gravity of this loading, means it will act at a distance L by 2. So the total load is PL, and now due to this PL, moment at A will be PL into distance between this center of gravity of load acting point and this A. So this distance will be L by 2 plus L. So I can write L by 2 plus L. It is a perpendicular distance, and the nature of movement is clockwise. So according to sign convention, clockwise movement is positive, anti-clockwise movement is negative. I am writing positive. Similarly, the moment due to this RB into this distance, that is nothing but L plus L plus L, so 3L. So RB into 3L, and the nature is anti-clockwise movement, so negative is to 0. So if we simplify it, we will get 3L by 2 minus RB into 3L equals to 0. So we will get RB equals to PL by 2. Now RA plus RB equals to PL by PL. So RA will be PL minus RB. So PL minus PL by 2 equals to PL by 2. So the reaction at A, it is RA equals to PL by 2 or RB equals to PL by 2. Now if you see this diagram here, if you see this diagram, then we can say it is symmetrical because the load is acting at the same distance from both the ends. So the reaction will be half of the total loading. So by this way also we can easily find out the reactions here. So there are two ways. If the loading is symmetric, then we can take the total load and we can divide it by 2, and we can say that the reaction at the two supports will be same. It is nothing but the total loading divided by 2. Or by applying the conditions of equilibrium, we can get these values. So we got these values by this way. I am again drawing the truss for our understanding. This is the given truss. Here it is a uniformly distributed load. Intensity is P per unit length. This length is L. Here there is one more member. Length is L, L, L. All are having the same length. These angles are 45 degree, 45 degree, 45 degree, and we know RA equals to PL by 2. Here RB equals to PL by 2. That is point B. A, C, D, E, and F. After finding the reaction, now we are interested in force in member CD. So we can easily apply the method of section here. We have to cut the section like that. It should pass through 3 or less than 3. So we can cut this section like this manner. So now draw the free body diagram, the smaller part. So this one is the free body diagram. Okay, see here goes to PL by P. Now we have to show the forces in cut members. According to our assumption, all the forces will be tensile, so away from joint, away from joint, away from joint. This is FA, this is FCE, this is FCD. So these are the members we have showed in this free body. Now if we extend it, it will meet at point E, and this distance is L, and this distance is also. So now apply equilibrium condition based on moment, that is algebraic summation of moments of all the force about E should be 0, that is E. So at E, moment due to A and CE will be 0 because line of action is passing through same point, so perpendicular distance will be 0. So I can write FA into 0, FCE into 0. Now moment at E due to this RA. So RA and perpendicular distance is L. So PL by 2, that is RA into L, and nature it is in clockwise direction. So positive, positive. And according to our sign convention, anti-clockwise direction is negative. Due to this FCD, at point E, moment will be FCD into perpendicular distance, that is L. FCD into perpendicular distance, that is L. And nature is in anti-clockwise direction, so negative is 0. So now we are having FCD equals to PL by 2. So this one is the value of force in CD in terms of P and L. It is nothing but PL by 2. So the correct answer is F. Now let's take another problem based on truss, which is asked in GET 2001. So EM GET 2001. In this problem, a truss is given as shown in figure. I am just drawing the members of a given truss. This one is the truss. I am just showing the members. And this one is point A, B, C, D, E, and this one is F. A is supported by hinge joint. and F is supported by lower roller support. And here we are applying the force of 1 kilonewton, and here we are applying the force of 1 kilonewton, and lengths are given, that is L and L here. Now in this problem we have to find force in CT. We have to find FCT. So for this problem we have to find the force in CD, FP, sorry, that is FB. We have to find the force B. So for this problem, if we take a section like that where the number of unknowns are 3 or less than 3, means we have to cut the section like that, we should pass through 3 or less than 3 members. Now we are interested in only on force B, so we have to apply method of section, and now we have to cut the section like that. We should pass through 3 or less than 3 members, but it should include the member B because it is our desired member. So I am cutting the section like that, and now draw the free body diagram of the smaller part. I am just drawing the free body diagram of the smaller part here. Reaction is RA. Here we are having 1 kilonewton. Here we are having the cut members. So now we have to show the forces in cut members according to our assumption. Away from joint, away from joint, away from joint. So this force will be FBD. This force will be FBE. This force will be FCE. So now let's check this angle is theta. So we have to apply conditions of equilibrium here. That is, suppose I am applying condition based on vertical forces. That is, algebraic summation of all vertical forces should be 0. So in vertical direction means along y direction, we are having the sign convention positive. Positive y is positive, negative y is negative for us. So if we apply this condition, that is algebraic summation of all vertical forces should be 0. So we are having FBE cos theta, that is in vertically downward direction, so negative. We are having RA reaction, that is in upward direction, so positive, and 1 kilonewton, that is in downward direction, so negative, equals to 0. So we are having FBE cos theta equals to RA. So RA minus RA plus 1. So we are having this unknown, that is RA. And if you see this structure here, it is RA and RF. So by seeing the structure, we can easily see that this is truss is symmetrically loaded, so reaction will be shared equally. So the total load here is 1 and 1, that is 2 kilonewton. So reaction will be equally means the load will be equally shared by both the supports, because both the supports are at the same distance, that is L, L. from each load. So the reaction will be here, that is 1 kilonewton. Reaction will be here, that is 1 kilonewton. So here we can easily write Ra is 1. So by this thing we will get P equals to 0. So the correct answer for this problem is B.